Hi guys, today we are going to talk about IP version 6. So before going into IP version 6, we were discussing about last week or previous lesson we were discussing about IP version 4. So you know about IP version 4. IP version 4, it is a 32-bit address scheme which is a decimal dotted number or decimal dotted notation, which is divided into 4 octets. Each octet has 8 bits, and they have two types of information. One is the network part, and the other one is the host part. So this one, it has the network details and it has the host details. That one is classified with slash notation or by classes or subnet masks. Still we can do subnetworks with the help of IP version 4, where we subdivide our networks into small different networks. Either we use fixed length subnet masking or we use variable length subnet masking. So this is how IP version 4 we were using. But all of a sudden what happened is, with IP version 4 we had a problem of accommodating all the devices with IP version 4 because of the exponential growth of devices. Literally nowadays almost all the devices which are being manufactured, they need an IP address. So now IP version 4 address could not manage to give IP addresses to accommodate all the devices. Why? Because the entire size is 32-bit and it is a binary, which means it is a base 2 to the power n. When it is 2 to the power n, that is 2 to the power 32, it means it can support almost like approximately 4 billions of IP address. When it was introduced in the 1990s or 1980s, when IP addresses were introduced, it was okay, because those days the devices and the networks were very less. So they imagining 4 billions IP addresses for devices was too big, and the design was sufficient. But today it is an exponential growth. It is not growing. The networking sector or the networking dependency is not growing, it is exponentially growing. So IP version 4 cannot accommodate all the devices. This is not happening today or yesterday. It is a long process. People have predicted the depletion of IP version 4 addresses long back, and they were trying to mitigate, trying to come up with a solution, a feasible solution, a viable solution for the depletion of IP version 4 addresses. So there are a lot of suggestions, or there are a lot of solutions, there are a lot of alternatives, out of which one of the best alternative or one of the next way to move through is the IP version 6. So when IP version 6 was designed, they kept in mind to meet or to mitigate all the pros and cons, all the drawbacks which is faced when using IP version 4. So the size of IP version 6 is 128 bits, which is compared to an IP version 4 which is 32-bit. When we just compare the number from 32 to 128, it seems to be a big number, but actually how big it is? Let's assume it is actually the double. How? Let me give an example to just show you, or to just make you feel how big is a IP version 6. That is, how big is 128-bit. So if you are going to use 1 bit, that means the possible outcomes from 1 bit is going to be one bit, it's a binary, so it is going to be base 2. So if it is 2 to the power n, which is 1, that is 2, that means I may be getting either a 0 or a 1. So that means I'm going to get 2 outputs. In case if I'm going to add another bit, if I'm going to add my second bit here, which is 2 to the power n of 2, which is 2 into 2, which is 4. That means I'm going to get 0 0 0 1 1 0 or 1 1, which means from 2, by adding one bit additionally, I get 4. So the same way, if I'm going to add another bit, the third bit, 2 to the power n, which is 3, which is 2 into 2 into 2, which is 8. That means I'm going to get 8 output, 0 0 0 0 0 1, and it goes on. That means from 2, the next bit I add, it becomes 4, the next bit it adds become 8, so it goes on, it doubles. So for example, here we have 32-bit, and from this 32-bit, imagine I have 32 bits here, this is 32-bit of IP address, and if I'm going to add one bit, it is going to be double the size of the existing 32-bit. It is not, we are not adding one part, we are adding the entire numbers from 2 to 4, from 4 to 8, 8 to 16, 16 to 32, it goes on like that. So in that way, I'm going to add 128 times or 128 bits, or additionally almost like 98 bits, which means that 98 bits or something, which means that it is a very big number. Like when I say you have 4 billion of IP addresses for IP version 4, you have 4 billion. Here you don't have a value to say. You just go and Google the number of IP addresses supported in IP version 6. It goes on. It goes on, the number goes on, trillions, billions, millions, trillions, and it goes on. I don't know how to call it. I had to Google it. I don't know how it is. So that much big it is, which means the first issue or the main issue of depletion of IP addresses in IP version 4 has been mitigated in IP version 6. Is that the only thing which is being addressed in IP version 6? No, we have a lot of advantages when we are using IP version 6. But now you might have a question, if we have a lot of advantages in using an IP version 6, then why we are not moving to IP version 6 and still we are using IP version 4? Always when we are mitigating, or when we think of bringing up a solution for any problem without any cons, without any drawbacks, then we would be understanding that a human cannot do that. If we are going to find out a solution for a problem, then there will be a solution for that problem, but there will be another problem which is arising, isn't it? The same way, migrating from IP version 4 into IP version 6 is a very big challenge, became a very big challenge, because the entire network architecture relies on IP version 6, and now to move it overnight is going to be a nightmare. We can't do it overnight. So there are options, or there are steps, or there are necessary actions which is being taken so that IP version 6 is moved entirely step by step, or we are moving slowly from IP version 4 into IP version 6 in a slow and steady pace. Okay, So IP version 6 almost mitigates all the issues or drawbacks which is being faced by IP version 4. So with this introduction, I will just move further and give you a clear picture of what IP version 6 is all about. Like I was previously telling you, an IP version 6, it is a 128-bit. When I say 128-bit, it is of big size. So it identifies or it mitigates the problem from the depletion of IP addresses. It can accommodate a lot of devices which is requesting for IP addressing. So what actually an IP version 6 is going to do? It is going to do the same task or same functions of an IP version 4. So now what an IP version 4 is doing? An IP version 4 is used to determine or to identify a host within a network. That means an IP version 4 has two parts of information. One, it has the network details or network information. The other one, it has the host details or host information. The same thing, IP version 6 is also having the network part and the host part. Okay, but we don't mean it as a network part or a host part here. Instead of calling it as a network details and a host details, here we call it as a global ID. The network part we call it as a global ID, and the host part we call it as an interface ID. But the function is the same. Okay, so instead of a network part and a host part, it is also classified into two major parts. One we call it as a global part, where it determines the network, and the other one we call it as an interface part, which determines the host. Okay, so out of this 128-bit, 64-bit goes for a global ID, and the remaining 64-bit goes for the interface ID. Okay, so this is how IP version 6 is classified. There are a lot of other functions which IP version 4 is having, which is not present in IP version 6, or which is not required for IP version 6. So there are a lot of examples. One thing is IP version 6 has made the structure very simple. So let's start with the structure. So the basic thing is about the extension of or the header of IP version 4 and IP version 6. IP version 4, the header is having a lot of information. It has its source IP address, destination IP address. It has the header file, the payloads. It has a lot of information. Even it has the routing details. It has all the information in IP version 4, which sometimes is not at all required. But here in IP version 6, this is not the case. It is kept very simple, that only basic things are added in a header. So now you may get a question: if I am going to add only the basic header files or basic information in my header files, what if my IP or my header file requires, or my devices require more information in order to transfer the packets? There is a possibility here in IP version 6, that is, it has the basic header which will be having the basic information. Like, what are the basic information is required? It needs a source IP address, it needs the destination IP address, and then it will be having what version it is using. So by default it is going to be a IP version 6, isn't it? So it will carry the version, and then it will have the traffic class, what traffic it is going to send. It will be having the flow label, what flow label it is going to have, and then it will have the next header details. What is the next header it is going to carry, the next header details, the hop limit, what hop limit it is having, and then it will be also having the payload. These are the basic requirements of a header file. Okay, so these basic informations are provided in a header file of IPv6. So what if in order to transfer a packet, if we need more fields, if I need additional fields to be added in this header file in order to communicate, or in order to transfer the packet, not to establish a communication. For example, it needs a routing information, or it needs the maybe security informations if you want to encrypt a packet. Okay, if you need additional information, yes, you can still add the additional informations. Okay, for example, if you need the TCP header, yes, you can add TCP header to it. Okay, this is how IPv6 works on. This type of header here in IPv6, we call it a extension header. We call this as a extension header, extension header files. That means IPv6 basically it keeps things very simple. So I am just revising what we were talking in all this time. We are talking about IPv6. So in order to understand the complete details of IPv6, you have to know about the IPv4. So as we were discussing in our previous sessions about IPv4, it is a 32-bit and it is divided into 4 octets. It supports, or it accommodates almost like 4 billions of IP addresses, and then it has a lot of informations within its header files. These are the things which we are discussing about IPv4, where we have a problem with IPv4. The problem is the depletion of IP addresses. It could not accommodate all the networking devices or all the devices which is requesting for an IP address. So we are moving from IPv4 to IPv6. We are migrating from IPv4 to IPv6. Even though we say that IPv6 is very advanced, or IPv6 is very easy to use, very convenient to use, to migrate from IPv4 to IPv6 completely all of a sudden is going to be very difficult. So we are moving step by step, process by process. We are making action plans to move. It is taking a long time, no doubts in that. So what is IPv6? The main purpose of IPv6 is to avoid, or it is to mitigate all the problems or all the drawbacks which we are facing in a network for an IPv4. So the first problem with IPv4 is the depletion of IP addresses, which is mitigated in, it is well advanced or sufficiently mitigated in IPv6 by accommodating, and the size is 128-bit. From a 32-bit, the IPv6 goes to 128-bit. When I say 128-bit, that is what I was giving you an example. 128-bit is not very comparatively from 32 to 128. It is actually very, very big. Okay. So the next thing we were discussing about IPv6 is always IPv6 keeps things very simple. They wanted to keep very simple. Okay. They don't want to put a lot of details, or they don't want to overload things with IPv6, which is actually being done in IPv4. IPv4, the header files has all the informations, and or in other ways, all the informations which are present in IPv4's header files is not used in the transit. So in IPv6, they have only the basic requirements which are required. So for a real-time example, let's say that you are traveling from from Swansea to any other part of the world. So maybe you are taking a flight. So in that flight, let's imagine you don't have you are not classified with two baggages. Like you don't have a cabin luggage. You don't have they didn't classify as a cabin luggage and your check-in luggage. Okay, like generally in a aircraft you have like almost 46 kgs of bags which you can put it in check-in, and then you can carry some 7 kgs with you while you travel. If you don't have that, and imagine you are permitted to take 52 kgs of entire baggage with you when you travel. So imagine how difficult it is going to be to carry it all the way into the flight, and then put it try to find a space for your baggage, carry that heavy weight of 20 kgs and then put it up. Even now we are facing it difficult to just accommodate a 7 kg of a bag, isn't it? So imagine if you're going to place 52 kgs within your head cabin, is going to be a nightmare, isn't it? So that is what happening in IP version 4. Even you use it or you don't use it, the header of IP version 4 has all the information within it, whereas here in IP version 6 it is not the case. They have only the basic things which are required. So what are the basic header files, or what are the basic parameters within a header files in a IP version 6? It will have the source IP address, the destination IP address. That when I say IP, it is a version 6. Okay, it will be having the source and the destination IP addresses. It has the version, which is version 6. It will have the other details like flow, hop limits, header, the next headers, what is the payload length, and all those stuff. Okay, so each one has its own size. Like for example, if you say the source and the destination IP address, then each one is 128 bit. Each one's the size of source and the destination IP address is 128 bit. If you want to check the payloads, then the payload is like I think 16 bits or something. So each one has its own size. Okay, so it has all those things. It is allocated with the size, and then it has only these things. Okay, and then you have the next hop limit, next header, the hop limits, and all those things. So each one has its own size, so it is determined, it is classified like how we have in our IP version 6 also. During our presentation, I will show you the original header file diagram, so it will be very easy for you to understand. Okay, so what happens here is, what happens if you need additional information for a particular data. So now, are you going to send it separately, or you can't send it, or how it works with the IP version 6? Yeah, it works. How it works? Whenever you need some additional informations which has to be added with your header file, yes, you can add. Like for example, you want to add a TCP header, then you can add a TCP header to it. You want to add security information like what encryption you are going to use, something, you can still add it. So whatever information, whatever headers you want to add, still you can add it. So that is why the header file here in IP version 6, we call it as an extension header. Okay, so that is the another advantage of using a IP version 6. Then in IP version 4, what is the next thing is we will be using natting in IP version 4. If you don't know what is natting, it is very simple. Like I think in our previous class we were discussing about natting also. Like it is a network address translation. What happens is in IP version 4, your local LANs, you are not going to use a public IP address. You will be using a private IP address, that is the the IP addresses in class A, class B and class C, which is reserved as a private IP addresses. For example, class C we have 192.168 series of IP address, right? That is the one which we use within the LAN networks. So you have two different LANs, and you don't want to have a unique IP addresses here. You can have both the local area networks can have the same IP addresses or the same range of IP addresses whatsoever, but if those private IP addresses, they can't be routed through the internet, isn't it? They can't be routed through the internet. So in order to route into the internet, you need a public IP address. So how do this private and public IP address communicate with each other? They do this NATing, isn't it? Network address translation. So from all these private IP addresses, they all NAT, and then they all mix together into this NAT, and it becomes one public IP address, and that public address is used or routed in the internet. It goes here. Here you will be having another NAT which translates this public address into the private IP address. So this is how it goes. This is the purpose of NAT. This NAT is not at all required in IP is private or public. So you don't have a necessity to use a NAT. But still there is NATing, or IP version 4, version 6 supports NATing. That one we call it as a protocol translation. Okay, we call it as a protocol translation. NAT protocol translation. What is this NAT protocol translation? See, for example, you have a network here, and this network is using IP version 6, and you have another network here. This network is using IP version 4. Or you have an internet here, and this internet is ISP or internet is using IP version 4. In any case, if an IPv6 needs to communicate with IP version 4, how is it going to possible? Because IP version 4 and version 6 can't work together. So how is it possible? In this place, you bring in this network address translation, this NAT PT. We call it as a protocol translation from a local IP version 6 to IP version 4, or from IP version 4 to IP version 6, vice versa, everything. So for that purpose alone, we go for a NATing, or IP version 6 supports NATing and we call it as a protocol translation. So this is another advantage of IP version 6. Okay, fine. The next thing what I wanted to tell is, I was telling that from 32-bit, the IP version 6 is now very big, 128-bit. Imagine remembering a 32-bit IP address which is actually in a binary, that is zeros and ones itself, was very difficult for us. Now imagine how are we going to remember zeros and ones for 128-bit? It is going to be really a nightmare, isn't it? Remembering a 7-digit or 10-digit mobile phone number itself is going to be a big challenge for almost all of us. I'm telling almost all of us, not everyone. In that case, remembering a 128-bit is going to be, imagine 000011110111 for one IP address. We are not going to do networking. We are going to throw ourselves out of networking, isn't it? Even that one is kept in mind. So in IP version 4, what we do is, from binary we convert it into a decimal format, isn't it? So we make it as decimal. So we convert the binary zeros and ones into 192's decimal. So we say 192.168.10.1 or something, and we try to remember it. Okay, so here, even if you want to remember in a decimal for 128, it is going to be a bit difficult. It's hard, isn't it? So IP version 6, it is not supporting decimal. we move to hexadecimal. So when we say hexadecimal, it means it supports 0 to 9 and then from A to F. That is a range. That is from 0 to 9 and then 10. Okay, let's say A, B, C, D, E, F. So it is going to be 10, 11, 12, 13, 14 and 15. 0 to 15, that means it is totally 16. Okay, so we are going to use hexadecimal. That means our IP version 6 address, not like our IP version 4 where it is limited from 0 to 255. IP version 4 is limited with 0 to 255, isn't it? IP version 6 is not that case. It is it will be with any of this one. It may be FA0, 1, 2, 3, 4, whatever it is. Okay, it will be from the range of 0 to 9 and A to F. How are we going to classify this? Okay, so it is very easy for you to understand. If you could understand this easily, if you could intake this easily, then it is going to be very easy for you to capture or remember IP version 6. Let me try to help you in that one. So for IP version 6, how it is going to work out, it is very simple. So what happens is, see, we have, okay, let's say it's a hexadecimal and previously we were using binary. So in that binary it is 32-bit. Okay, IP version 4 is 32-bit and this one is 128-bit. So if you're going to represent a binary into a hexadecimal, so binary is 2, hexadecimal is how much? Hexadecimal is how much? How much is the value of a hexadecimal? It is like 16, isn't it? So 0 to 9 and then from A to F, so it is 0 to 15, that is totally 16. That means if you are going to convert, or if you are going to use a hexadecimal instead of binary, one hexadecimal is equivalent to 16 bits of a binary, isn't it? Okay, so that means I'm going to use the same part. So here I am going to use one hexadecimal. So when I am going to use one hexadecimal digit, that means in binary I am going to use how many? 1, 2, 3, 4. Do you get me? So that means how I am going to divide it is, so 1, 2, 3, 4. 4 hexadecimals, which is, when I say 4 hexadecimals, which means 4 binary plus 4 binary plus 4 binary plus 4 binary, which means 4, 8, 12, 16. So one slot of hexadecimal, one portion of hexadecimal, which is of 4 parts, it is going to contain how many bits? It is going to contain 16 bits. Okay, so totally 16 bits. 4 portions of hexadecimal is going to be 16 bits. So how many bits of how many parts of hexadecimal you want to have? So you let's say this is part 1. So like this, you have 2, 3, 4, 5, 6, 7, 8. Let me put it on the same size. Okay, so you will be having 8 portions, 8 parts. Do you get me? So 1, 2, 3, 4, 5, 6, 7 and 8. So this is the structure of your IP version 6. Right? So I will make you clear again. I will repeat this portion again. Right? So we already discussed that we are going to have 128 bits. Okay, the size of your IP version 6 is 128 bits. So previously you are well clear of your IP version 6, isn't it? Sorry, you are clear with your IP version 4. So for IP version 4, so let's say for IP version 4 you have 32 bits, so you are going to have 32 bits here. Totally this is 32 bits. 32 bits you have divided into 4 parts, that is 8 bit, 8 bit, 8 bit and 8 bit, right? So you will be having 8, 16, 24, 32. So totally 32 bits. So you will be saying that this one in a decimal, so it is 192, 168, 1.10, something like that. So in IP version 6, you are using the same strategy, you are using the same method, but if you are going to divide it into 8 octets, I mean octets as octets or 8 bits each, it is going to be again a big value. So instead of that, what you are going to do is you are going to put 4 parts of hexadecimal. Okay, so 4 parts of hexadecimal, and then again you are going to add 4 parts of hexadecimal, and then you're going to have 4 parts of hexadecimal, and then you have a block. You again have 4 parts of hexadecimal, and then block. You have again 4 parts of hexadecimal, and then you block it. And then you block it, and then 1, 2, 3, 4, 5. Again you have 4 parts. There is a block. Again you have 4 parts. You block it. So how many? This is the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, and then you have the last bit. So this is the 8th one. So you totally divide it into 8 portions, 8 parts. Okay, so that means, are we going to accommodate 128 here? Because here we are dividing into 4 parts, each octets, 4 octets, which comes to a total of 32 bits. 8, 16, 24, 32. So here, if you are going to divide into 8, are we going to get 128? Yes, we are going to get 128. How? See here, this one hexadecimal part is 4 bits. Okay, so you have 4 bits, 4 bits, 4 bits and 4 bits. That makes 16 bits. So again it goes 16 bits, 16 bits, 16 bits, 16 bits, and it goes on like this. So totally you are going to get 128 bits. That means the structure of your IP version 6, the structure of your IP version 6 is 8 portions. One, 2, 3, 4, 5, 6, 7 and 8. So that 8 portion is going to be categorized as any value which is in the range of 0 to 9 and A to F. So maybe F0, 1, and then, so how are we going to separate it? Is it a dotted decimal number? No, it is not a dotted decimal number. Instead of that, we are going to use a colon. Okay, so I say 0, 0, 0, 0, another 0, 0, 0, 0. Fourth part is 1, 2, 3, 4, and then fifth part is A, B, C, D. Sixth part is 0, 0, 0, 0. Seventh part is 0, 0, 0, 0. Eighth part is 5, 6, 7, 8. Something like this. Okay, so the range, this is the structure of your IP version 6. So in this structure, you have to make sure that there are some specification. That is, first thing, your IP version 6 is not case sensitive. It is not case sensitive. So either you are going, it is not case sensitive. It is not case sensitive. Either you say A or you say A, it is the same. Do you get me? So the next one is like how you write your value of your money, isn't it? So for example, let's say the first thing is not case sensitive. The second one, if you have 100 pounds with you, how are you going to write your 100 pounds? So you can write your 100 pounds like this. So for example, you go to a bank, okay, and the bank is having a column like this, and they want you to fill the money, the pounds. So you are going to transfer, you are going to send 100 pounds. How are you going to represent the 100 pounds? Are you going to put 100 here, or will you make a 100 here? The best way is to make a 100 here, because if anyone is going to add a value here, or you are going to add a value like 0 here, it is not going to add value for this original 100, isn't it? Okay, so any number of zeros here in the front of the original value is not going to add value. The same thing here in your IP address, in your IP version 6, let's say instead of 5678, here you have 05678, and instead of here you have 1 2 3 4, you have 0 1 2 3 4. So maybe yeah, here you have FF01. So you have something like this. The second point is, first point is case sensitive, it is not case sensitive. The second point is the leading zeros you can ignore. What is the leading zeros here? Anything which is in the front, they are the leading zeros. For example, here 0 is leading, so either you say FF01 0000, I will come to this all zeros later, 0000. Here you can say either 0234 or you can say just 234. It is the same value, okay, and then you say ABCD, and then you say 0000 0000, and then here you say 678. So in this case, if it is not 678, if it is 0078, and then here you can just say 78. So the second point here in representing an IP version 6 is you can omit the leading zeros, okay. And the third one, there are 3 rules, okay. The third one we will be doing is, we will come to these zeros, the consecutive zeros we have, okay. The third one we will come to the consecutive zeros, okay. The point here is, when you are going to have successive zeros, you can just represent it with a colon, okay. So for example, here in our case, you have successful zeros here, you have successive zeros here, not successful, successive, okay. So can I make all these things with a colon, double colon? No, you can't do that way. You can select any one, okay. Okay, for another easy understanding, let's make this one also 0000, okay. If our IP address is this way, let's assume that this is our IP version 6, FF01 0000000234 000000000000, and it is 078. So if it is that case, where you have here 2 consecutive zeros and here you have 3 consecutive zeros, you can't make all these two, this one and this one, you can't make both with semicolons, or you can, both the things can't be, both successive zeros can't be made as represented using double colons. Instead of that, you can choose only once, okay. One out of this you can represent with successful zeros, Why? Because here if you mention both the sides as successful colons, and that means here you have two successive zeros, and here you have 3 times successive zeros. Now there will be a confusion that which one is 2, which one is 3, isn't it? So whether I should have 3 successive zeros here or I should have 3 successive zeros here. So you can use it once, so you can use it anywhere. FF01, here I'm going to put, okay, so I can just avoid the second point, the leading zeros, isn't it? Either I put 0 or I put 0, 0, 0, 0, both are the same, isn't it? So I put 0, colon, 0, colon, 2, 3, 4, colon. Here, instead of me putting the 3 zeros here, I just put double colon here, okay, and then I put 7, 8, which means that I am telling this is my IP version 6. So now it says that FF01, here it is 10, so totally there will be 4 hexadecimal digits here. So it will automatically take 4 zeros here, 0, 0, 0, 0. Again here it will take automatically 4 zeros here. Here it will take 0, 2, 3, 4. Here, see, listen here. Here I didn't omit the 0 because this is not successful 0. So we should put that. Here it says that, okay, I have double colon, so some successive zeros are here. Again, okay, we will come to it later. Here we say 0, 0, 7, 8. It will add things. And now it says we need totally 8 parts. 1, 2, this is first part, second part, third part, fourth part, and 5 parts are there. So how many remaining? 6, 7 and 8 are remaining. 3 parts are remaining. So here in between I am having 3 successive zeros. Do you get me? Okay, so I repeat it again. There are 3 points which represents the structure of an IP version 6. One, it is not sorry, it is not case sensitive. Okay, it is not case sensitive. Second thing, you can omit leading zeros. Third, you can use colon, double colon for successive zeros only once in a IP address. So this is how you can represent the structure of your IP address. I guess you are clear with this introduction. It is being a long introduction. I will give you a break now. Just take a break. We will meet with the second part where I will just revise what I have described so far, and then we move into the next part of our IP version 6. If you have any doubts, please let me know.